alaikum, ladies and gentlemen. Welcome back to another live stream. I'm just joking. Alright, everyone, welcome back to another live stream. This is part 3 of this guide, and let's get going. Alright, let me share the stream real quick. Copy. There you go. And let's go. And yeah. Alright, so I'm not honestly sure what we're gonna go about today. Probably loading textures without any libraries, but we'll see how it goes. I'm not entirely sure. So last part I was trying to make a new extension working that I never used before, and of course that failed horribly. And I couldn't get it to work, unfortunately, at least for now. So what I've done, I've just followed the tutorial, honestly, when it comes to buffers. You know, just the traditional way without any extension, for now at least. It's pretty simple stuff. I also got a staging buffer on too. So we're basically... let's see what I've done here. Unfortunately, I forgot to, use Git before I've done the changes, but I'll try to hopefully cover the changes that I've done so far. Nothing too fancy, but basically we're creating 3 buffers right now. We're creating a staging buffer, which is going to be on the host, right? It's host visible and host coherent. And the vertex buffer and the index buffer are supposed to be in the VRAM, so they're faster to access. So device local bit, device local bit. So they're only going to be accessible to the device. And then I'm basically copying all the data that I want to stage to the GPU, to the VRAM, to that staging buffer, right? So I'm mapping that memory, then I'm copying the vertex data into the staging buffer, and also the index data to the staging buffer, plus some offset of the vertex data. So of course I don't want to override the what is it called? I don't want to override the vertex data. I want to actually store the vertex data alongside the index data in the staging buffer, and after that I can map it. And then I basically allocate a new command buffer, right? And then I basically tell the GPU to copy from the staging buffer to the vertex buffer, and the same thing with the index buffer. We have size. The only difference here is of course the size, and here the offset. So while here the offset is 0 for the vertex data in this case, source offset here is actually size of vertex data. Okay, and then we end the command buffer, we actually submit it, and finally we wait for the fence. So we wait for the GPU to do the operation. And that's basically it. Too simple. We still got the same triangle, but right now we're actually using buffers instead of hard coding stuff up. So that's great. Okay, so today I actually managed to decode images only using the Win32 API. So there is this COM component in Win32. It's called the Windows Imaging Factory, I think, or something like that. Hold on, Win32. Let's go. So the Windows Imaging component provides a component object model COM-based API for use in C and C++. The WIC API exposes a variety of image-related functionality, including built-in codecs for the standard web image formats, built-in support for standard metadata formats, wide range of pixel format support, high color support including 30-bit extended range, 30-bit high precision, and 48-bit high precision and wide gamut pixel formats, an extensible framework for image codecs, pixel formats, and metadata formats. Now, the problem with this is that while indeed they say it is for use for C and C++, but I couldn't find any resources on how to use COM libraries on C++, especially this component, this Windows imaging component, except for one resource. So if you check for how to use, what is it, Win32 COM in plain C. Yeah, the only resource that I found is this, and it basically tells you how to actually create a COM component from scratch. This is a real hidden gem. I learned so much from this post. So it basically teaches you how to create a COM object from scratch in C, just plain C. And from this, I derived on how can I use this WIC, the Windows imaging component, the COM component from C, only C, without going to C++. So I guess maybe that's what I'm going to try to do today. We're going to try to decode some images and then basically upload them to the GPU so we can use them in our mesh for texturing, hopefully. And we'll see how it goes. We'll see how it goes. Alright, so I guess let's get started maybe. Okay. So let's take the tutorial as a reference here. Where is it? Texture mapping. Okay, images. Hold on a second. So as long as we use system libraries, we should be fine. Since we're not including that in our own binary, it's always going to be included in the thing. Here they usually just use stb, but anyways, so create texture image. So first of all, we gotta load the image, right? And then we gotta use our staging buffer. And then we gotta load that into an image. We gotta allocate an image, I believe. And there you go. Initial layout. Okay, I think let's get started pretty much. So let's start by actually loading an image. Let's see. So first of all, we gotta actually initialize the COM library. So you do it like, I don't know if I remember how to do it actually, but let's see. So co-initialize. Hold on. Interesting. I'm not sure which header this is in. Actually, let's just include the Win codecs first of all. Include Win codec.h. Okay, there you go. Cool. Now let's actually co-initialize null ptr, and this gives us an h result. hr is equal to this. Now if this have failed, right, if failed hr, well, honestly right now we're just gonna debug break, I don't care. Right, so there you go, just so we know that it actually failed. Okay, there you go. So this will basically go ahead and initialize some stuff for the COM library. Now what's next? We gotta do some interesting stuff. We gotta load the imaging component. Let's see if the AI could help us here. Yeah, imaging factory. There you go. Did it get it correct? Yes, it did, interestingly. Alright, so basically, if you look into the actual code here, what is it called? Yeah, let's go here. So if you look into the example code, this is how you actually do it in C++. So you just say id ppv args p factory thing, right? And then you say this weird stuff, right? Now in C, we don't have that. We actually have to do it, manually. So code create initialize, you give it that. Now here you give it a reference instead of just that. And also here, instead of this macro that we don't have, we just say we pass in the interface GUID, right, of the component and the reference to where we want to put it, basically. And that's essentially it. Let's make sure that this doesn't fail. And there you go, it didn't fail. So we have loaded that successfully. Great. Now what's next? We gotta actually load some images. Well, first of all, let's actually put this image in factory in our abstract. Let's go. There you go. Document using. Oh yeah, I need to include that thing up there. Hold on a second. So Windows, Vulkan, blah blah blah, and codec, there you go. Okay. Now we're gonna say app imaging factory. I think so. Dot actually here, and yeah, that's basically it. We're gonna load the imaging factory, and then right now we need to start loading some images. Load image from file. Okay, so first of all we need decoder. Create decoder from file name. Yeah, correct. Let's go. What's up? Cannot result. Oh yeah. So right now it's trying to use the C++ way of doing it, which is incorrect for our case. So let me show you how you do it in C++ first of all. Okay, here you go. So in C++, this is how you do it. You just create a decoder pointer, right? And then you just call the member function create decoder from file name. But of course, we do not have classes in C++, in C, right? But C++ classes are just like structs with a dispatch struct inside of it. And here's how you do it in C. Pretty much, you just say LPV table. This is this dispatch table. It's basically just a table of function pointers. This is basically what a C++ class under the hood. That's literally it. Just an array of function pointers. Anyways, so create decoder from file name, and the coloring is broken for some reason. There you go. Okay, cool. So you basically use the LPV table dispatch, right? So you call that function pointer and you pass in the same struct, right? So in C++ class you have this pointer, when you say this something. Well, we don't have that in C, but internally this is what happens. Every function in that dispatch table is just gets called with the first argument as the struct, This is basically how C++ classes work under the hood. Anyways, so here we give it the file name in Unicode, and here we just can prefer some particular vendor. This is not interesting. Null PTR, meaning we're not preferring any vendor. Generic read, the file permission that you want to get. I don't think you need anything else other than generic read, honestly. This is decode metadata cache on Lloyd and bitmap decoder, where we want to put it. Great. So it failed. We're just going to debug break for now. Okay. what's next? We're gonna load the first frame. Well, for a PNG, it will always be, you know, one frame, but for you know, GIF, like this library can actually supports GIF. So then you have to actually use a function to get how much frames in the image, and basically load every frame from the image separately. But we don't care about that. We only care about PNGs and such right now. So bitmap decoder index 0. There you go. So again, the same thing. The struct, you know, you get the table, then you call the function pointer with the same struct that you started with, and that's basically how it works. Next up, alright, load first frame. Now we gotta convert to the format 32-bit BGRA, which is usually the format used. I'm not sure actually if Vulkan uses that. Maybe it uses RGBA instead, but I guess we could easily change that anyways. Whatever. So the format converter, if failed app image in factory, create. Good. Let's go. So we just create a format converter. Now we initialize the format converter. Okay, bitmap frame. Here you actually tell it the format you want to convert to. So even if you load a grayscale image, for example, you could still use this format converter to, you know, have the same format for all images essentially. Anyways. These are for certain cases which we don't care about right now. Also this one, but this is what is interesting. Whatever. So what's up here? Expression of type frame decode is explicitly converted pointer. Yeah, this is just some inheritance stuff. So we could just silence that, meaning that we acknowledge that. And we think it is okay. Alright, great. Next up, we gotta actually do the decoding by copying the pixels. But before that, we need to allocate some place to actually put that image in. So for that, I'm actually gonna put this into its own struct, honestly. Now later on, I may make this more efficient by basically creating one decoder for each file type I wanna support, and then reusing that decoder. But for now, to keep things simple, we're just gonna put this whole thing into its own function. Load image from file. We gotta start somewhere, and yeah, load image from file. Cool. So let's grab that, and we're basically gonna say void image, right? We're gonna put that there, and actually this would return H result, you know, for failure, because we do want to handle failure in this case. Actually, this is some process that is very prone to errors. Okay, so now I'm gonna have a struct actually called, let's say, I'm honestly not sure. Well, maybe let's call it image, okay? And it would basically contain this bitmap decoder, right? Bitmap decoder, it's going to contain the bitmap frame, the format converter, and finally, well, not really. That's not really the image, but maybe should we call it a image loader or image decoder? I don't know. I mean, I guess let's call it maybe the image decoder actually. Fine, maybe. So now we got the image decoder. So basically here we do need the application though. So app, right? No return statement. Okay, cool. Where's the HR result thing? Hold on a second. What the heck? Come on, bro. Stupid IDE. Anyways. So, how we're gonna do this? Debug. Oh, crap. What? Failed debug break. Yeah, remove this from here. No return statement in a function returning non-void. Yeah, if we reach the end, then we're just going to return SOK, which is similar to vacate success. Now we also need the file name, actually. Yeah, and yeah, we do need an image decoder struct. Basically, in fact, this should be type diff really. So type diff struct image decoder, and there you go. Cool. Now, come on, bro. Should do it manually. Fine. Okay, let's convert that, because right now it became a pointer. And yeah, there you go. So here we're gonna pass in the file name. There you go. Okay, do this. Doing this. What else? Return this. Okay. Okay, so it failed. What we're gonna do actually, we're gonna return that HR. Yeah, so hold on, go back. We're gonna make an HR result here, or H results, right? HR, and it failed. Then we're gonna basically, instead of debug break, we're just gonna return the HR. And here we're actually going to say, hold on. Let's take this, say HR is equal to that. What's up? Can be joined. Well, I guess okay. So it failed HR, then we're gonna return the HR, too simply. And what else? There you go. Same thing with these. Give frame. So just remove this actually and say HR is equal to this. Same thing with these. Right. And this one too. There you go. What's up now? Okay, remove this maybe. Let's go. And now let's just copy this if failed return HR, I guess. Okay, load first frame and convert that, and yeah, I'll just check. Actually here, since this is the last operation that, well, actually this is not the last. The last operation would be actually getting the width and the height of the image, really, because we're gonna need that to allocate memory for it and to create the image. So what we're gonna do, we're gonna get the image size. Yep. No, just say, fine, bitmap frame. Okay, cool. So let's go with bitmap frame. Oh, actually, hold on a second. What the heck? I forgot, yeah. Let's remove these. We're gonna actually use the struct instead now. Right, let's go. Now, just gonna say app bitmap decoder. What's going on? Oh, oopsies. No, not app. Decoder. So we're gonna say decoder, bitmap frame, decoder format converter, decoder here, here. What else? Is that it? I think so. Maybe we could add const there. Cannot resolve symbol bitmap decoder. Let's put that there too. Now finally, let's get the image size. And let's go. So this should put the width and the height of the frame into the struct. Great. What's up here? Oh crap, okay. The other thing that we're gonna do also is Enloid image decoder, I guess. Or let's just call it Enloid image anyways. And here, add const. And yeah, correct. If decoder bitmap decoder, then we're gonna release it. And if bitmap frame, then we're gonna release it. And yeah, so basically COM components are actually reference counted. So you could like release them and acquire them. Anyways, so Lloyd image, great. Now what? Okay, so after we load the image, let's try to load some, sample image here. Let's make some, well, not development resources. Let's go with resources. New folder. Oh yeah, I also have gone back to one shader binary, which contains both the fragment and the vertex, because I'm not using that pointer reference stuff anymore, which was messing with it. Also, I've edited the script a bit, so I'm just testing if resource and resource/shaders is in there. Then I'm removing it, and then I'm basically making a new directory, resource/shaders. Then of course I'm compiling the shaders, right? And after that I'm linking the two shaders together into one shader, and then I'm removing the intermediate shaders basically. But anyways, and also my git ignore, it's ignoring the resources. Oh crap, no, I see. Interesting. Well, actually that's a bad idea. We shouldn't ignore resources right now. Yeah, I see. Yeah, anyways, whatever, it's fine for now. So let's just take some image out of here. I have some Kine assets around here. Let's see, 3D assets, I guess. I don't know, 2DS voxel pack, sure. I don't know, let's take maybe this for example, this little PNG, and let's put it into images here, I guess. There you go, now we got this image right here. Let's try to load it now and see if it works. Alright, let's just say load image, and we're gonna say app and resource path images slash texture dot j, well, not jpeg, it's gonna be images slash sample 3d dot png, and here I don't know, let's put an image decoder here, I guess. Image decoder. Of course, we gotta initialize it because my enloading logic depends on it. So basically here, if anything is initialized, so we could basically use this enload image even if there is an error, like if the object is partially constructed. Since we have these if conditions, as long as the thing is initialized by null pointers at the start, it should be good to go, even if an error happens. Cannot convert app to parameter type app const. Yeah, good. And yeah, let's go. Now let's see if we can get the width and the height. Message, well, print image size. Let's go. Just use a message box, I guess. Huh. Interesting. Fine, just use printf. Let's not complicate things. Let's go. Let's see if this works. Unused variable HR. Interesting. It failed. Yeah, I indeed didn't use it. Interestingly. So it failed, then, well, return 1, I guess. Let's go. Okay, there you go. So 918, 515. So we got that out of the way. Let's see if it is correct. And there you go. Great. So now let's actually decode it, because right now we still haven't decoded it actually. We just loaded the stuff needed for decoding it. Okay, great. So let's actually write a function to decode this stuff. Decode image. There you go. So decoder, of course, this actually would return H result really. And by the way, since this is the last one, why not just, you know, return that directly instead of checking if it's failed and stuff. Okay, this is the same thing. We're gonna return it directly. So here we actually have a stride. So it's gonna be uint, I guess. Stride is equal to that, and so this would be the stride, and here would be the stride times the height. And of course, this is basically the pointer where you want to copy the decoded pixels into. Now, I could have just allocated memory using whatever, like global alloc, but I don't want to do that, because what I'm gonna do actually, I'm gonna allocate memory through Vulkan. I'm gonna allocate, or actually, yeah, it's just gonna be the staging buffer maybe. I'm gonna get a pointer, and then I could feed it to this guy, and it would just copy directly without having to allocate an intermediate thing, you know, which is gonna be great. That's why I actually have made these two separate steps, so I could actually do that. I could have used a callback maybe, but that would be a little bit annoying to work with. Okay, the nice thing also about this is that you could actually give a rect of a specific portion of the image, which is amazing. But let's not overcomplicate things for now. This is fine. So yeah, okay, cool. So let's try to decode this image, but before that, we have to, so this is, honestly, I don't care anyways. Now let's just say this, let's just decode the image, but how are we gonna do this? I don't know what to call the function, honestly. Let's call it Lloyd texture, fine, yeah, okay, sure. Let's call it Lloyd textures. Actually, we're gonna load the textures with the buffers, really. Let's actually do it here for now. Let's do it with the buffers, because we're gonna use the staging buffer there, I think. So yeah, so before we stage the memory stuff, let's do it here, I guess. Well, we need the functions. Okay, there you go. No need for a library, it's all in the system. It's all in the system. Decode image. Load the image. Oh crap, I always forget. Come on. Let's grab this whole thing and let's take it just before create buffers at least. Okay, let's go. So Lloyd image expression of type. No, right now it's just gonna be app like that. Okay, we're loading the image here. Now here we're gonna need to actually create a vacay image. Let's see if the AI could help here. Interesting. Well, we gotta load the the functions first. Actually, that's right. Okay. Now create the image, please. There you go. Cool. Nice. So image type 2D, sRGB, BGRA8. Great. Extent image decoder width, height. Great. So this is what I was talking about. Let's go. Before we actually decode anything. Tiling optimal samples 1 bit. Transfer DST. These transfer DST because we're going to be using the command to actually transfer data using the GPU to that buffer, or in this case the image. Use it sampled bit. I'm not sure we're gonna need. Yeah, we're probably gonna need that. Yeah, the initial layout probably should be fine. Anyways, so here cannot resolve symbol image. Okay, sure. Let me give you an image. And oh, before I forget, let's actually run the Vulkan configurator real quick for debugging purposes. Overriding, validation, break. Good. So what the heck is going on with this guy? What's up? What's up? What's up? I don't know why this got broken this bad. Okay. Anyways, image. And here we're just gonna give it to the image pretty much. And there you go. That's how you create an image. But this is an image without memory, at least not yet. So we gotta allocate some memory for it. Okay. Yeah, let's go. Image memory, memory requirements. Same deal. Memory type index. App memory properties. What the heck? How did I use find memory type again? Where is it? I used it with memory properties. Okay, let's just copy this for now. It's spaghetti code, but anyways, let's just make it work first. So how are we gonna do this? Memory requirements. Let's do it here, I guess. Sure. And let's remove this. Okay, great. It's gonna reside in device, right? Great, in the VRAM, sure. And then what? Memory type index. So now I think we gotta bind it. Actually, we gotta allocate. We still haven't allocated anything. So come on, allocate the thing. There you go. Okay, allocate, allocation size, memory requirement size. Great, lovely. Cannot resolve. Are you kidding me? Didn't we just use it here? No, we didn't. Or is it? Yeah, it's actually in the buffer function. Yeah, I see. Well, that suck. But okay. Right here, right here, right here. Spaghetti. Let's go. So that's some allocation right there. Now we gotta bind it. Do we even have the bind thing? Probably not. There you go. And now let's bind this thing to its memory. And let's go. There you go. Cool. So now after we have done this, we have to make sure that the buffer staging, the buffer is long enough or big enough. Okay, plus size of index buffer, interesting. Can we load the image before that? Probably we can. Yeah, sure. Let's go ahead and do that actually. Actually, let's do it before this guy. Let's go. So we load the image, and now here plus size of vertex data plus size of index data, and now we're gonna say plus width, probably with well, image decoder width times image decoder height times 4 bytes, right? Yeah, I think so, because it's RGBA for components, 8-bit. And there you go. Cool. Hopefully that should be good enough, unless if I missed some alignment stuff, then that's gonna be rough. Okay, so that's basically it, I believe. Now we just gotta copy the data. And honestly, this is getting real messy real quick. Let's first of all, hold on a second, go back to, yes, here. Take this guy. This is the image size, right? So size t const image size, there you go, cool. And what's next? We're gonna actually, so instead of doing it this way, maybe we could do this. Maybe we could have like a cursor or whichever. So size t cursor, I guess, is equal to 0, right? And then we're gonna mem copy. Buffer staging data. Yeah, plus cursor here. Plus cursor. And here we're just gonna say cursor plus that. Finally cursor plus that, and finally we're gonna mem copy the image, and there you go. And then we're gonna in-map the data, gonna in-map the buffer. Okay, great. Function result should be used. I don't care for now. Okay, great. So I think that's basically it for that one. And next up, we gotta make sure to copy the data out of there. I think I'm gonna do the same thing here. Gonna have like a cursor, I believe, just to make things simpler, maybe. Cursor is equal to 0. Source offset. I'm probably gonna put this in a loop or something like that later on. Anyways, so that's the cursor. Cursor plus equal to size of vertex data. And so again, we're gonna say cursor. Okay, next up, bro. Let's go. And finally, we're gonna copy the buffer for the image. Oh crap. Well, this is interesting. We're gonna be copying from the buffer to the image. I didn't expect that. There you go. Okay, forgot about that. Let's go. So what's up now? Expression type is implicitly convert to compatible point. Oh no. This is not the right command. Bad AI. CMD. What the heck was? Oh yeah, we haven't loaded it yet. My bad. I see. Okay, let's go ahead and do that actually. Vacay. What is it called? CMD. Copy. Buffer to image. Exactly. Let's go. And now let's try to do this. So after this, there you go. Okay, so from the staging buffer, right? Yeah, from the staging buffer to the image line transfer DST optimal. Okay, region count, one region. Layer count with height. Yeah, seems good to me. And let's see if there's any error, honestly. Local variable size sticker size. Oh, I see. Makes sense. So where it's defined, yeah, here. Okay, cool. So we do not need to do this. Now let's go ahead and run this up. Pointer of type using arithmetic. Yeah, I see. Oh well, how are we gonna do this? I guess we're gonna basically cast it, just like here. Gonna cast it first of all to char pointer instead of void. And that should do the trick, I guess. Right? I think so. Let's run this now. And there you go. Fake EQ submit. Okay, so what's up? Invalid image layout. Command buffer expects vacay image to be in layout. Vacay layout transfer this instead current layout is. Oh yeah, makes sense. Makes sense. I guess maybe we could actually do that in the initial layout if I remember. Yep. Let's see if this would work. Right. So this is gonna be transfer DST optimal, right? Yeah, destination. And let's go, because like the copy commands are transfer commands. Anyways, so what's up now is but must be undefined. The initial line must be okay. Interesting. Oh well, so why put it then? Okay, anyways, so it seems like we gotta actually do the layout transition ourselves. I think we're gonna use the pipeline barrier for this. Let me though see how the tutorial did it. I do, if there's like a easier way to do this other than the way I'm thinking about. Let's see. Copy buffer. Okay, there, transition image layout. Okay. So how he's doing? Oh yeah, it's basically doing the same thing that I was thinking about. Okay, fine. Let's go ahead and do it. Vacay get image memory. Well, before we actually do that image thing, where is it? The image. Do we have the pipeline barrier thing here? I don't think so. Come on, there you go. Cool. Okay, so now we're gonna use that. And before we do the command copy buffer to image, we gotta make sure to actually transition the layout. There you go. No need for this. We're not doing any key family transitions here. Undefined is 0. We don't care about the layout, the old layout. Great. Vacay access transfer right bit. Yep. We don't care about the src access mask. And yeah, pretty much. Stage transfer bit. Great. I think that's basically it, really. Let's see. I mean, it didn't crash. So I guess mission successful, maybe? Maybe we could actually see if it worked in RenderDoc before we go with the pain of actually setting up the descriptor sets and so on. See if it's a failed mission already. Let's see. Launch application, executable path. Okay, I find it very, very annoying that I have to, every time I relaunch RenderDoc, I have to copy the thing. It doesn't persist the path. But whatever. So where's my build? Here you go. Let's say, I guess Control Shift C, maybe. There you go. make sure that the working directory is correct, the root directory of my project. And yeah, I think that's basically it. Allow. I don't know. Okay, great. Now let's try to do this. So we got a capture there, and let's see. Where can I even find that actually? Maybe the resource inspector, possibly. Where is my image? Where is my image? Image. Sort by. So we have some swap chain images. And we got one image. What the heck? Where's my image? Interesting. Oh, maybe it's not included here? Or what? What the heck? Doesn't seem like it's included here, actually. Well, let me try something actually. Maybe we could do Q capture frame 0. No? Captured frame 0? Did it just crash? What the fuck? Oh my god. I hate when it crashes. Come on, I gotta do that shit again. And code oxel. Okay, Q capture 1 frame, frame 0. It crashed again. Let's try with frame 1. Okay. Code oxel and key capture. Let's go with frame 1. Let's try this out. Nah, I quit. No way. What the heck? Anyways, I guess we just gotta basically set it up and see if it works. Oh crap. Anyways, so let's actually go now to here, and let's see how we can set this up. We're gonna need some stupid what is it called, descriptor sets, I believe. So let's go ahead and do it. Yep. Image view and sampler. Yeah, we're actually gonna need the image view first of all, actually. Let's create an image view then. Where is an image view? So where we create the image, where, there you go. Okay. So I'm not sure if we could actually create an image view while it's still not allocated some memory. I don't see a problem with that, but no clue. We'll see. We'll find out, I guess. Sure. Oh crap, no. Make it create image view. Cool. Layout count sRGB. Seems good to me. And yeah, let's make sure the image view is created successfully. And we got a stick trap. Okay, yeah, it should be after binding some memory. Okay. We're binding it here. Go ahead after that, create an image view for that. Okay, we're creating an image view successfully. Okay, cool. Now what? What the heck? Why they're talking about... Oh, I guess basically he abstracted it away. Okay, cool. No filtering, bilinear filtering. Okay. Alright, so we gotta create some samplers right now. Vicky physical device properties and max anisotropy. Anisotropy. Border color and normalized. But how do you... Okay, Vicky create sampler. So we gotta create a sampler. Okay. And then what? Combined image sampler. Okay, let's create a sampler first of all. So here's our image creation stuff. Cool. So auto const vk create image sampler. Let's go. Now let's create an image sampler. So I guess we could do it here. vk sampler, there you go. Create sampler. This is fine for now, I don't care. We just want this to work. vk create sampler is not there. Why? What? Why did this? Interesting. Let's go. Okay, great. So now what's next? Let's make sure this works. It works. Let's go to the next step. Okay, so now we gotta deal with that stupid descriptor set stuff, which I hate. Buffer info dot range size of uniform buffer object. Max frames in flight. Okay, so I think we're gonna need the descriptor set right now, pretty much. So I don't know when to create it, honestly. Maybe let's create it somewhere around here. Possibly create descriptor pool, sure. And then we're gonna create descriptor set layout. Okay. We're gonna create descriptor sets, I believe. There you go. Is there anything else that I forgot? I don't think so. Yeah, that's pretty much it. Okay, so descriptor pool is pretty easy, mostly. Void create. Oops. Crap. Come on, bro. Okay, let's go. Now let's see what's going on. Combine. Okay, great, lovely. But hold on. Yeah, true. We do need that field, basically. So we're gonna have one set for now, one pool size, and it's gonna be a combined image sampler. It's gonna be only one. Okay, cool, great, amazing. Next up, create descriptor set layout. Lovely. So binding count 1, binding 0, image sampler, stage fragment. Okay, cool. The AI so far seems to be knowing exactly what I'm looking for. Amazing. Let's go ahead and go to the next step. Create descriptor set. Alrighty. Let's create this field too. So we're allocating some descriptor sets, of course 1 for now, using that descriptor pool, using the descriptor set layout, and then we're updating the descriptor sets. Okay, get device proc addr, dst binding 0, descriptor count 1. Sampler. Okay, so I think this is the one that we need right now to actually set the image stuff, right? Am I right? I think so. I think so. Let's see if they have that here. Oh yeah, there you go. There you go. That's what I'm talking about. Where is the image stuff? There you go. Okay, but where is the actual image? It's image info. Oh yeah, there you go. Texture image view and texture sampler. Great, we are on the right path. Alright, let's just grab this one right now. And we're gonna put it in our texture stuff. Where is our texture stuff after we create our textures and samplers and so on? In fact, we could just do it here, I believe. Yeah, vk update. Come on. Descriptor sets. But before that, of course, there you go. So we got the image view that we have created, and we got the sampler that we have created, and that should hopefully be it. DST binding, descriptor count. Now we're just gonna figure out how to use it from the shader, I believe, if I didn't miss anything, hopefully. Hopefully. Let's go. We're gonna need UV too, but let's not worry about that right now. We could just use the vertex position for now for that as a placeholder. But what we really need right now is where's the sampler though? I'm pretty sure. Okay, there you go. There you go. Okay, so just gotta take this, right? Go to the fragment shader. Let's go here. Uniform binding, probably 0. Sampler 2D text sampler, and finally we're gonna say out color is equal to that. We're gonna sample the image, and if everything goes into plan, we're gonna have our image displayed. Oh my god, if this doesn't work, I quit. Just joking. Anyways, let's see what's gonna happen. So let's run our script. Scripts slash compile shaders. Yeah. Oh crap. File does not exist. Huh. Fractex core in the card identifier. Oh yeah, my bad. We need the actual UV. Okay, gotcha. Makes sense. So we have to do some fractex chord here. Well, we could just pass in the position of the vertex for now. And how we're gonna do that? Well, good question. I forgot. We could do it like this. So in our frag, I believe, guess that's our input, right? And that's our output, fractex chord. There you go. Let's go to our vertex. Let's put that guy there. And right now, just gonna make sure to set it. Yeah, something like that. Who cares? And that should do the trick, hopefully. There you go. That seems to be fine, I guess. And the moment of truth. Oh crap. Let's see. But was not declared in the pipeline layout. If a resource of variables is declared in shader descriptor line. Gotcha, it makes sense. Okay, let's go to the pipeline layout because it seems like we need to do something there too. Create pipeline layout. Let's see what we got here. P-set layouts. Okay. Great. Come on. Is that it? Yeah, that's pretty much it, really. I think. Okay, let's see. Come on, please. Oh my. Okay, so the Wiki pipeline created with Wiki pipeline aesthetically. This descriptor set index 0, which is not compatible with the currently bound descriptor sets pipeline layout. For each set and that is statically used by bound shader. Oh, hold on a second. Oh, actually I'm not binding this descriptor set, my bad. Let's go to the well, for example, where we bind the vertex buffers and such. Okay, great, here. So first of all, we need the function, a new function. Where can I load it? Yeah, I need to load it in Lloyd Vulkan functions. Okay, let's go ahead and do this. Nope. CMD. Exactly. And let's actually create this field. Let's go. And now let's go to where we're binding the index buffer and such. There you go. And let's actually bind our thing before we draw. Exactly, man. Let's go. And hopefully this works. Oh crap, bro. Come on. Command buffer expects Wiki image to be in layout. Oh yeah, I need to do another image layout, transition. I see. Okay, so where we're doing that, loading the image thing, let's go. There you go. Okay, so after we, hold on. Okay, so here, after we copy the thing successfully, we're gonna basically transition it back. Well, not back, but we're gonna transition it from transfer to shader read only optimal, from write to read, and yeah, that's basically it. Oh, yeah, it works. Let's go. Let's go, man. There you go, bro. There you go. Not using any libraries, just Win32, just, the system libraries. Crazy. Just amazing, man. Oh my. Now let's just add some UV. Let's add some UV to this, and let's make a quad. Alright, well, let's actually start by a quad first of all. So let's go where we're actually having the vertices stuff. Where I have my vertices, bro. There you go, okay, cool. So we're gonna add another coordinates. So we have that, and we have that. So what is gonna be? We're gonna create a quad. No. Okay, so what thing we don't have here? I mean, we have the 0, we have the 0.5 and minus 0.5. Which combination we don't have? Crap. Actually, no. Let's just let the AI do its thing. Oh no! Come on, bro. Quad 4 vertices. Like, come on. Let's see. What? Bruh. Oh yeah, I mean that's correct actually. Yeah, I see. Now the thing is, it doesn't know that I have indices. Okay. But it's fine. It's fine. Yeah, as long as it can do its thing, then it's fine. Yeah, go ahead and do triangle 1. Okay, hold on. I probably have, let's just do this, okay? And now, come on, bro. Triangle 1. And then triangle 2. Okay. And let's just say, I'm not sure why it's doing it this way. It's kind of weird, isn't it? Yeah. So we could just do it like this, like this, like this, like this. Okay. And yeah, I'm not using the index right now optimally, but who cares? Okay. And let's see if this works. One triangle isn't correct. One triangle isn't correct. Well, it's fine. So minus 0.5 f minus 0.5 f. So we got negative, right? And we got positive, negative, positive, positive, negative. We already got this, so no need for it. Positive, positive. We don't have that there. Negative, positive. We got that already. So this is the vertex we needed actually. Now we just gotta figure out the indices. Or let the AI do it. Let's see. I mean, I really expected the AI to actually do this, honestly. But somehow it didn't figure it out. And yeah, I didn't figure this out. So I just have to do it myself. Alright, fine. Let's try to do this. Okay, so we got minus 0.5f, minus 0.5f, which should be, I guess, somewhere around here, right? Minus 0.5f. Yeah, and then 0.5f in the x, minus 0.5f. Well, which triangle is not showing up, first of all, actually? Hold on. Which triangle is not showing up? So 0, 1, 2 is fine. Now, what we just need is... Let's see that. Come on, are you kidding? Okay. 0, 1, 2. So then it should be 0, 1. So it should be 1, 2, and finally 3, I guess. Oh crap, man. Now I know what's the problem. And I thought I was losing my mind. I guess I had a lot of coffee, man. Yeah, I know what's up. I know what's up. It's fine. I know what's up. So let's go to our draw command. Oh my. Yeah, the AI was right all along. But it can't protect me from my stupidity. Okay, let's go ahead to, what is it called? To the vertices stuff and indices. Come on. Man, what did I call it? Are you kidding? Okay, there you go. Let's try this out now. Should work. There you go. Now it works. Let's go. That's what I'm talking about. That's what I'm talking about. And we can in fact even do this really. And we will have a simple image viewer, I guess. Right? Let's see. And there you go. Let's go, man. Let's go. Now we're loading the images using Win32 and actually displaying them. Let's go. Whee! Very cool. Now we gotta clean up this mess and make it reusable. Also, we don't want linear for this. We're not using pixel art here. Let's go, I guess, with bilinear. What the heck? What kind of filters there is here? Why it doesn't show me? Oh, what? There isn't? There's just cubic and it's behind an extension. Interesting. Okay. Weird. Fine. And alrighty. Okay. So now what should we do actually? I don't know what's next, to be honest. I think maybe I'm gonna stop the stream at this point. I think maybe this is enough for now. We have made a little texture. So yeah, that was it for the live stream, and see you later. Goodbye everyone.